This video is on Unit 3, Chapter 7, Rational Exponents and Radical Equations, Lesson number 3, Solving Radical Equations. In your notes here, steps to solve radical equations. Step number one says to isolate the radical on one side of the equation. So basically in that first step, we have to make sure that we get the radical all by itself. Step number 2, you're going to raise each side of the equation to the power of the index to eliminate the radical sign. I'm going to talk more about that here in just a second. Step number 3 says to solve the remaining equation. And then step number 4 says to check for extraneous solutions. So a couple of things we need to talk about before I even get started on the examples. So in step number 2, it says to raise each side of the equation to the power of the index. And the reason why we want to do that is because of opposite operations. So if I've got a square root of x, to undo the square root, we square it, and the square root and the square cancel each other out, and we're left with just x. The same thing is going to happen if you have a cube root of x. Again, in order to cancel the cube root part, we have to cube that radical to get just the x. The same thing is going to hold true for the fourth root, the fifth root, and so on. So the reason why you're raising each side of the equation to the power of the index is because those are opposite operations and they cancel each other out. Now I want to talk to you also about extraneous solutions. Extraneous solutions are solutions that you're going to come up with while you're working this problem that don't actually work in the original equation. So again, extraneous solutions are solutions that don't work in the original equation. And y'all, that's going to happen when we raise those sides to an even power. When you raise both sides to an even power, anything that's negative becomes positive. And that could create what we call extraneous solutions. So the directions here tell us to solve each equation and then be sure to check for extraneous solutions. So looking at example number 1, it says the square root of x plus 5 is equal to 12. The first step is to get the square root by itself. So we're going to subtract 5 from both sides. When we subtract 5 from both sides, we have the square root of x is equal to 12 minus 5 is going to be 7. And then that is a square root. The index is 2. So we're going to raise both sides to the second power. And when we square and square root of x, we get just x is equal to 49. Again, you need to make sure you check your answer. Because this was a square root, an extraneous solution is definitely possible. So if I substitute that back into the original equation, am I going to get a true statement? And that's what you've got to check for. So the square root of 49 is 7 plus 5 does equal 12. So that checks out, which means that x does equal 49. I want to look at number 2. In example number 2, we've got 3 minus the fourth root of m is equal to 0. So the first step here is to get the radical by itself. And we can do a couple of different things. Most of you are probably going to subtract the 3, which I'm going to do that. 0 minus 3 is negative 3. And then you'll notice that there's still a negative in front of the radical. That's like a negative 1. So we need to divide both sides by that negative 1. That's going to leave me with the fourth root of m. Negative 3 divided by negative 1 is a positive 3. Now that I've got the radical by itself, I'm going to raise both sides to the power of the index. I'm going to raise this to the fourth power. And that's going to make the radical go away, giving me just m equals, and then 3 to the fourth power is 81. And again, you must go back and double check. So I've got 3 minus the 4th root of 81. Is that really and truly equal to 0? Well, 3 minus 3 does equal 0. That checks out. So M does equal 81. Jump down to number 4. I've got the square root of 6w minus 5 plus 10 is equal to 3. Notice that the plus 10 is not under the radical, so I've got to get rid of that. We're going to subtract 10. And I've got the square root of 6w minus 5. 3 minus 10 is negative 7. And then the index is a 2. I've got the radical by itself. The index is 2, so we're going to square both sides. And I get 6w minus 5 equals negative 7 squared is 49. It is positive because negative 7 times negative 7 is positive. Then we're going to add our 5. 49 plus 5 is 54. And then divide by the 6, and we get w equals 9. And then again, we're going to take that back, and we're going to check our answer. So going back to the original, 6 times 9 minus 5, and then plus the 10, is that equal to 3? So 6 times 9 is 54, and 54 minus the 5 is going to give me 49. So I got the square root of 49 plus 10. Is that equal to 3? Well, 7 plus 10 does not equal 3. I think you can see that at this point. It's going to be 17. 17 does not equal 3. So W equals 9 is not a true statement. The answer to number 4 is going to be no solution. You can write it out. You can use your symbol for no solution, either way. But there is no answer to number 4. The answer that we got, the 9, was created right here when we squared a negative 7 because it made that negative number positive. Moving on to let's look at number 6. So number 5 and number 6 are very similar. I want to look at number 6 first. So we've got, in parentheses, 7p minus 1 raised to the 1/3 power plus 11 is equal to 7. So the 7p minus 1 to the 1/3 power is the same thing as a radical. You learned that in lesson number 2. Your exponents that are fractions are radicals. And what you're going to have to do is you're going to have to train your brain to look at that as a radical. And the index is a 3 because the denominator is 3. The index is 3. I'm going to subtract the 11 first because remember, the rule says get the radical by itself first. So 7 minus 11 is negative 4. And then some of you, if it helps, you can certainly change that to the cube root of 7p minus 1. If it helps you to rewrite it like that, that's great. Do it. Totally up to you. I'm just going to go ahead and right here raise both sides to the 3rd power. And what that does is it gets rid of that exponent. And we have left just the 7p minus 1. And then negative 4 to the 3rd power is negative 64. And then I'm going to finish solving it, add the 1, and we get negative 63. And divide by 7, and we get p equals negative 9. And again, we're going to go back and we're going to check that. So I've got 7 times negative 9 minus 1 to the 1/3 power plus 11. Is that equal to 7? Inside the parentheses, 7 times negative 9 is negative 63. And then negative 63 minus 1 is a negative 64. To the 1/3 power plus 11, is that equal to 7? Well, remember that 1/3 means the cube root. The cube root of negative 64 is negative 4 plus 11. Is that equal to 7? And it is. It does check out. So P does equal -9. So back on number 5, you would divide by the -9 first. And again, that C minus 12 to the 1/2 power is the same thing as a square root. So then you would square both sides. I want to look at number 8. On number 8, there's a couple of things we've got to take care of. On the radical, there's a -4 in front and an 18 behind it. The 18 is being added, and we need to get rid of that first. So I'm going to subtract the 18 first. -2 minus 18 is going to give me -20. And then we're going to divide both sides by the -4. So the radical hasn't changed yet. And then -20 divided by -4 is a +5. And then at this point, once you get the radical by itself, you're going to raise both sides to the power of the index. The understood index is 2. So we're going to square both sides. And I get 43 minus 3x is equal to 25. And then we're going to finish this out. We're going to subtract the 43. 25 minus 43 is -18. And then divide both sides by -3, and you get x equals 6. And again, you must check your answer. Go back, plug it back in. Is that equal to 2? And I'm totally okay if you want to stick that in the calculator to check to see if it's equal to 2 rather than doing it mentally. I'm okay with that. Let me show you that really fast. So -4 times the square root of 43 minus 3 times 6. That was all under the radical. The plus 18 was on the outside, and this is supposed to be equal to I think I've got a problem. A -2. And then that was a -4. I left off the -4. I'm so sorry, you guys. That was a -4, not a -1. -2. Okay, so that's how you do it wrong and then do it right. Checking it in the calculator. Again, just plugging in that left side of the equation so that the calculator can quickly spit out that answer, and you can double check and make sure that x equals 6 does work. So moving right along, looking at number 9, 10, 11, 12, on all 4 of these, we have radicals on both sides. So in this instance, there's no way for us to get the radicals isolated. Now we can do certain things to maybe make it a little easier, but basically there's no way to isolate. That's what you need to take away from this. There's no way to isolate. So what we're going to do is just raise both sides to the power of the index. So let's look at number 10 first. And on the left side and the right side, the index is a 4. And I'm going to raise both sides to the 4th power. And that makes those radicals go away. We're left with 27 minus 2d equals d minus 3. And then solve from there. I'm going to subtract the d. So I'm going to take away this d. 27, -2d minus a d would be -3d equals -3. And then I'm going to subtract the 27. -3 minus 27 be -30. And then divide by -3 and we get d equals 10. And again, we raise both sides to the 4th power. It is very important that you're checking your answer. You want to take that back to the original problem and double check that it actually works. On this, 27 minus 2 times 10. 27 minus 20, so that would be a 7. I'm going to be left with the 4th root of 7. On the right side, I've got 10 minus 3, which is 7, so I have the 4th root of 7 over here as well. So that works, and D does equal 10. Let's look at number 12. So on number 12, there is a number in front of one of your radicals. Again, we have radicals on both sides. There's no way I can get my radicals isolated because I have 2 of them. So I'm just going to go ahead and raise both sides to the 3rd power. And this is the tricky part. The right side's the tricky side. The left side, the radical just goes away, and we've got 14 minus 10n. But on the right side, it's like your exponent is going to distribute to the 2 numbers that are on the inside. You have to raise the negative 2 to the 3rd power, and then, of course, the exponent and the index are going to cancel each other out. So negative 2 times negative 2 times negative 2 is negative 8, and the cube root of n cubed is just going to be n. So we have a negative 8n on the right side. And then what we need to do from here is just finish solving. I'm going to add the 10n. Negative 8n plus 10n is 2n. Divide by 2, and we get n equals 7. Again, you have to check. For time's sake, I'm just going to go ahead and tell you that it will check out. When you substitute 7 in, it will check out. Moving right along, I want to look at number 14. On number 14, I have the square root of 12 minus a plus 7a is equal to 8a. We can isolate our radical here by subtracting the 7a. So the square root of 12 minus a equals 8a minus 7a is 1a. Our index is 2. We have the radical isolated. So now we can raise both sides to the 2nd power. And I have 12 minus a is equal to a squared. Now what just happened here is we just created a quadratic. And this is going to go back to chapter 5 where we were solving quadratics. You're going to pick the method that you want to use. I'm going to move the 12 and the negative a to the right side. So it's going to be a squared. I'm going to add an a and subtract the 12. And I've got my 0 on one side, and I can very quickly factor this. 2 numbers that multiply to give us a negative 12 that add to give you a 1 will be 4 times negative 3. So this is going to factor into a plus 4 and a minus 3. And again, it's quick because the leading coefficient is a 1. And then we're going to solve both of those. So a plus 4 equals 0, which means a equals negative 4. And our a minus 3 equals 0. So a equals positive 3. Now, in this instance, you have to make sure you check both answers. You have to check the negative 4, and you have to check the 3. So I'm going to show you that really quick. Let me erase this table. I'm going to substitute in the negative 4 first. So that's going to be the square root of 12 minus negative 4 plus 7 times negative 4. Is that equal to 8 times negative 4? So underneath the radical, 12 minus negative 4 is plus 1 is 16. So the square root of 16 is 4. And then 7 times negative 4 is a negative 28. And 8 times negative 4 is negative 32. So is that going to be equal to each other? 4 minus 28 would be negative 24. Does that equal negative 32? No, it does not. So negative 4 is not an answer. The negative 4 was created when we squared the a. because that -4 would have become positive there. So that is what we call an extraneous solution. You would do the same thing with the 3. So I've got 12 minus 3 plus 7 times 3 equals 8 times 3. So under the radical, I've got a 9. 12 minus 3 is 9. This 29 is 3. Plus, I'm so out of room here, 21. Is that equal to 8 times 3 is 24? And it is. It does check out. So A does equal 3. Moving on down to number 15, 16, and 17 are all very similar. I want to look at number 15. Let's just do 15. So on number 15, the radical's already isolated. So we're going to square both sides. And the radical goes away, and I have 6m minus 38 equals. Now, this is where students will mess this up. When you square m minus 5, it's m minus 5 times m minus 5. So we have to FOIL. We get m squared minus 5m minus 5m plus 25. So all of that is going to simplify to m squared minus 10m plus 25. So that is where I worked out squaring of m minus 5. Now, if you'll notice, again, we have a quadratic. So I'm going to subtract the 6m. Negative 10m minus 6m is negative 16m. And add the 38. 25 plus 38 is going to be 63. And that's equal to 0 now. I got rid of everything on the left side. I got a 0. I'm going to factor again. Two numbers that multiply to give me 63, that add to give me negative 16 are going to be a negative 9 and a negative 7. So that's going to factor into m minus 9 and m minus 7. And when I solve that, we get 9 and we get 7. Once again, you have to make sure that you check both answers. And for time's sake, I'm going to tell you that they both work. The 9 and the 7 both work. I want to look at number 17. Number 17 is going to make us mad by the time we're done. So number 17, it's just like number 15. I'm going to start it out by squaring both sides. Then I get 51 minus 5y equals, and then when we square our y minus 11, we get y squared minus 11y minus 11y plus 121, which gives me y squared minus 22y plus the 121. That may take you a minute to get used to doing that, but you're just squaring a binomial. I'm going to bring the left side to the right side to get my 0 equals y squared negative 22 plus 5y. Negative 22y plus 5y is negative 17y. And then 121 minus 51 is going to be positive 70. So then I need two numbers that multiply to give me a positive 70, that add to give you a negative 17, which would be a negative 7 times negative 10. And again, the leading coefficient here is 1, so I'm just going to factor into y minus 7 and y minus 10. Solve, and we get y equals 7, and we get y equals 10. Now, again, you have to make sure you take those back and plug them both in. And what you're going to find is that neither one will work. Both of these are extraneous solutions, and the answer to number 17 is no. solution. So it is possible when you're working these out that both of the solutions that you come up with do not work, or maybe just one of them will work, like we saw in number 14, or in number 15, both solutions worked. Just being upfront so that you kind of know what's coming, it is totally possible. Because of the, when we square both sides or even raise both sides to the fourth power, if it's an even index that you're raising both sides to, it can create those extraneous solutions. So those are your notes for chapter 7, lesson number 3 on solving radical equations.